In this video, I will show you an AC circuit. See here, I have a resistor of 3 ohm and an inductance of 0.0127 Henry. Now see, this resistance R and the inductance L, they are connected in series. So this circuit will be a series RL circuit, and in the circuit we are applying an alternating voltage V equal to 141 sin 100 phi t. Okay, now see, for this series circuit we have to calculate the RMS value of the steady current and relative phase angle. Number 2, write down the application for the instantaneous current. Number 3, find the average power dissipated in the circuit. Number 4, determine the power factor. Number 5, draw the phasor diagram and impedance triangle. Number 6, calculate the real, reactive and apparent power. Okay, now let me proceed with the solution of the circuit. Here we are applying the alternating voltage V equal to 141 sin 100 phi t. Now see, if I compare this equation with the standard sinusoidal voltage V equal to Vm sin omega t plus phi naught is the initial phase, you will see here I will get Vm is equal to 141, omega is equal to 100 phi. Now see, we know omega equal to twice phi f, so I can write 100 phi with twice phi into 100, twice phi into 50 hertz. So you will see our f will be 50 hertz. Now see, the initial phase of the applied voltage is equal to 0, so phi naught will be equal to 0 degree. Now see, what will be the RMS value of the applied voltage? We denote the RMS value in case of the circuit with capital V. RMS value will be equal to magnitude of that RMS value, phase angle. Here phase angle will be 0. Here magnitude will be Vm divided by root 2 and phase angle is 0 degree. Vm is equal to 100 volt, Vm equal to 141 divided by root 2, phase angle 0 degree. So here I will get 100 phase angle 0 degree, and if I write it in the rectangular form I will get 100 plus j 0. This is the RMS value of applied voltage in phasor form. Now see, we know the value of applied voltage equal to 100 phase angle 0 degree or 100 plus j0. At first we have to calculate the RMS value of the steady current. Now see, we have resistor of 3 ohm and inductance of 0.0127 Henry, and we know the frequency of the applied voltage, which is equal to 50 hertz. Therefore, as this is a RL series circuit, we can easily calculate the impedance of the circuit. Impedance of this RL series circuit will be Z, which will be equal to R plus J XL. The XL is the inductive reactance, which is equal to twice phi FL. Here R is equal to 3 ohm plus J into 2 phi, F is 50 and L is 0.0127. Therefore you will see I will get impedance equal to 3 plus J 4 ohm. In the polar form I can write it 5 phase angle 53.1 degree. Now see, I know the value of RMS voltage, I know the value of impedance. I can easily calculate the RMS value of current. RMS current I will be the ratio of voltage by impedance. Here RMS value of voltage is 100 with phase angle 0 degree, and the impedance will be 5, phase angle will be 53.1 degree. Therefore you will see our current I will be 5, phase angle 53 point. So the current will be equal to 20, phase angle will be minus 53.1 degree. So this is the RMS value of steady current, and we have to find the relative phase angle. See, the initial phase of the voltage is 0 degree, and the current has a phase of phi I is equal to minus 53.1 degree, and our phi V is equal to 0 degree. Therefore the relative phase angle or phase difference phi D, which is equal to phi V minus phi I, here it will be equal to 53.1 degree. And here you will see current I lags voltage V by angle 53.1 degree, because the angle of current is negative. Okay, we know the RMS value of current, which is equal to 20 phase angle minus 53.1 degree. This is the RMS value of current. Now what will be the value of maximum current? We know that RMS current I is equal to maximum current divided by root over 2, because this is a sinusoidal quantity. So here I can easily calculate maximum current IM equal to root 2 into RMS value of current. It will be 1.414 into 20, which will be equal to 28.28 ampere. Okay, so I am done with step number 1. After that we have to write down the expression for the instantaneous current. See, here it is obvious from the phase angle of voltage and current. Phase angle of voltage is 0 degree and phase angle of current is minus 53.1 degree. This indicates that current I lags voltage V by an angle of 53.1 degree. Now see, therefore I will write down the expression like this: I equal to Im sine omega is equal to 100 phi, so 100 phi t minus 53.1 degree, and the maximum value of current will be 28.28. so I will be equal to 28.28 sine 100 phi t minus 53.1 degree. Okay, so I'm done with step number 2. In step number 2 we have to write down the expression for the instantaneous current. This small I indicates the equation of instantaneous current. Small I. In number 3 we have to find the average power dissipated in the circuit. In a RL series circuit, average power dissipated is equal to real power of a series RL circuit, and we calculate that by multiplying RMS value of voltage into RMS value of current into cosine phi, and this will be exactly equal to the current square into resistance R. Here RMS value of current is given by 100. Here you will see RMS value of voltage will be 100. RMS value of current is equal to 20, and phase difference between voltage and current is 53.1 degree. This cosine phi will be phase difference between voltage and current, 20 into cosine 53.1 degree. You will see this will be equal to 1200 watt, 1200 watt, or if I calculate I square R, here you will see I square R will be equal to, I square is equal to 20 square and R is equal to 3. So this will be the average power that is absorbed in this circuit, or that is absorbed in the resistor, will be 1200 watt. The inductor, in a full cycle, the inductor does not absorb any power. During positive half cycle it takes power from the source. In the next half cycle it releases that power to that source, or it returns that power to that source. Okay, therefore over a full cycle the power in the inductor will be equal to 0. I have shown you earlier. Number 4, we have to calculate the power factor. How do we calculate the power factor? We can take the cosine of the phase angle between voltage and current. Here it is equal to 53.1 degree. This will be equal to 0.6. Now see, as our current I lags V by 53.1 degree, therefore our power factor will also be lagging. We can calculate the power factor by using also this formula. Power factor equal to P R by Z. Here R has a value of 3 and Z has a magnitude of 5, which will be equal to 0.6. Or we can calculate power factor by taking the ratio of VI cosine phi, real power divided by apparent power. Here VI cosine phi is equal to 1200 watt and VI is equal to 100 into 20. It will be 1200 watt divided by 2000 watt. This will be 0.6. Okay, so our power factor will be 0.6, as current I lags V by 53.1 degree. Our power factor will also be lagging. Number 6, we have to calculate the real power, reactive power and apparent power. Real power. Real power is equal to average power of the circuit, average power, which is equal to RMS value of current, RMS value of voltage into cosine phi. RMS value of voltage is 100, current is 200, current is 20 into cosine 53.1. So this will be 1200 watt reactive power. Reactive power will be equal to VI sine phi. V is the RMS value of voltage, I is the RMS value of current. 100 into 20 into sine 53.1 degree. This will be equal to 1600 var volt ampere reactive. And the apparent power is the multiplication of RMS value of voltage and RMS value of current. RMS value of voltage is 100 and RMS value of current is 20. So this will be 2000 volt ampere. See, in point number 5 we have to draw the phasor diagram and the impedance triangle of the series RL circuit. Here we have resistance R equal to 3 ohm and inductance L equal to 0.0127 Henry. Now see, the impedance of this RL circuit is equal to 3 plus J4. So at first I will show you the impedance triangle. R is equal to 3 ohm. It will go in the direction of reference, and the imaginary part is J4. Therefore, let's say this indicates J4. So this is 3 ohm and this is J4 ohm. If I add this real and imaginary part, I will get our impedance. Impedance is equal to Z, which is the sum of real and imaginary part, resistance and reactance in phasor form. So this will be our impedance triangle. And see, this J4 will create 90 degree with the reference axis. So this will be 90 degree and this is a right triangle in which horizontal axis indicates resistance R, this vertical axis indicates reactance X, and this axis hypotenuse indicates impedance Z. Okay, now let me draw the phasor diagram or the voltage triangle of this circuit. In this circuit, the current I, RMS value of current which is flowing all over the circuit, is equal to 20. As this current I equal to 20 ampere remains same throughout the circuit, I will take I equal to 20 ampere as our reference, and I will denote that with line segment OA. I will take this OA in this direction. This is O, this is A. This indicates our current phasor I. Now see, our voltage phasor VR, which is the voltage drop across this 3 ohm resistor, will be I into R equal to 20 into 3. This will be 60 volt. Okay, now see, if I take the current phasor which is indicated by this green arrow in this direction, VR will go in the same direction, because in a resistor voltage across it VR and the current through it are in phase. So I will take VR equal to 60 volt in the same direction as our OA, and I will denote this VR with OB line segment. This is OB and this will indicate VR equal to 60 volt. Okay, now see, VL is the voltage across this inductor equal to IXL, which will be equal to 20 XL equal to 480 volt. Now see, the current that is flowing through this inductance is I. If I take I is in this direction, the voltage across the inductor, if I denote that with VL, VL leads current I by an angle of 90 degree. Therefore I will take VL of 80 volt in this direction. VL of 80 volt in this direction, and you will see this applied voltage V, which was equal to 100 volt RMS value. 100 volt and 0 will be the sum of this 60 and this VL. V will be 100. Now let me show you how. See, if this B, I will denote that this with C. VL will be BC. So see, this will create a 90 degree angle with the reference I. So this angle will be 90 degree. See, I have drawn the phasor diagram of the circuit by using the voltage components, and this is a right triangle, so this triangle is known as voltage triangle. In which hypotenuse square OC square, which is equal to V square, will be equal to OB square plus BC square equal to VR square plus VL square. So our V will be equal to root over 60 square plus 80 square, which is equal to 100 volt. Okay, that's it. Thank you.